Hi everyone, welcome back to the lecture series on graph neural network. So in today's lecture, we will be analyzing a social network by using a graph neural network. So this is an implementation lecture and in the first part, we will briefly understand what we are trying to do in this project and then we will see how we can implement this. So I hope there are many beginners watching this lecture and I have tried to make it as easy as possible. And I have tried to create the project such that everyone can understand and relate with this project. So let us see what we are doing in this project. My name is Aiswarya Nandakumar and welcome to the video. So we have a university and there are students coming from different countries in this university. So it is observed that students coming from the same country tend to interact more with other students of that same country. So we will analyze the connections of these students, how they are interacting with each other. We will analyze their social interaction network and then we will classify the students based on their respective countries. So here we have the university and students come from 4 different countries, A, B, C and D. These students interact with each other, but mostly with the students of their same countries. So we will analyze their interaction pattern and based on that, we will classify the students into their respective countries. If you have seen my previous lectures, then you will have an idea about what are the nodes and edges of a graph. So here, the students forms the nodes of the graph and the friendship is the edges of this graph. So we will use graph convolution network for classifying the students into their respective countries. So we will understand what graph convolution network is in detail and how we can implement that. And by using this GCN, we will classify the students based on their nationality. So we will be using the famous Karate Club dataset for doing this project. So we will load the Karate Club dataset and we will modify the dataset such that we can create a synthetic dataset of students coming from 4 different countries. Then we will generate random edges, which is the interaction between the students. And then we will classify the students based on their countries. We will use libraries like PyTorch Geometric Network X and Optim, and we will see how we can beautifully visualize our graph and how we can visualize the embeddings, etc. So let us get into the implementation. All right, so now let us see how we can implement this. So this is an implementation lecture. So I will not be covering the theory in detail. So you can watch my previous lectures in which I have covered what are the different types of graphs, what are the different kinds of tasks which we can perform by using a graph neural network, etc. So in this lecture, we will be trying to analyze a social network by using a graph neural network. So we will classify the students of a university based on the countries from which they come by using a graph neural network. So we will be using a graph convolution network in this lecture and let us see how we can do that. So first, we install all the required libraries. I install Torch Geometric and Octuna. Torch Geometric extends the PyTorch to provide the layers and necessary tools which are required for building and training our graph neural network. And Optuna is a hyperparameter optimization library. So by using Optuna, we can select the best hyperparameters needed for training this model. And by using Torch Geometric and Optuna, we can build, train, and optimize our graph neural network. So it will take some time to run this part of code, but it is okay. And after this, I'm importing all these required libraries like Torch Geometric datasets, then Torch Geometric Utils, Network X, Matplotlib, NumPy, etc. for building and training our graph neural network for classifying the students of a university. So let us see why we import all these libraries in detail. So Torch is used to define and train our model. So like it provides the foundational tools for tensor operations within our graph neural network. Then as I already said, we are using a dataset called Karate Club dataset in this project. So we will load this Karate Club dataset. It is already available in this library torchgeometric.datasets. So this is a quite famous dataset used for graph neural network. So we will load this dataset and then we will modify that to create our own dataset of students belonging to 4 different countries in a university, and we will try to classify them. Then this network X library is used for creating, then manipulating and analyzing the nodes and edges of our graph. So this is a very useful library. And We will use this torch geometric utils to convert our PyTorch data object into a network X graph so that we can visualize our graph. So this will help in our visualization process. Then, as I already said, network X library is used for creating, manipulating, and visualizing our graph. So we use Matplotlib for visualizing our graph and creating plots. So here we use it for plotting our graph and plotting our embeddings. So we can visualize the embeddings which are formed by training our graph neural network. And we have NumPy. NumPy is the most common and fundamental library which we use in Python. So this is a mathematical operations library. So here we use NumPy to perform different mathematical operations like random sampling, and we use it for assigning different students to different countries from which they come, and we use it to manipulate the arrays during the data preparation stage. Then we have this torch.nn module. This contains classes for building the neural networks in PyTorch, and then we use this torch.nn for defining the layers of our GCN. So we are using a graph convolution network here. So we use this module to define the layers of our graph convolution network, and this provides us the tools to create a fully connected layer which is used in our network. And together, these libraries support our process of building and training our graph neural network, and it also helps to visualize our graph neural network. So next, what we do is we load this Karate Club dataset. So as I already mentioned, this is an already available dataset in Torch Geometric Datasets library. So we directly load this dataset from there, and we are going to modify this dataset for creating a dataset of students who come from 4 different countries. And let us see how we can, let us see what this dataset is and what are the different nodes, edges, and features of this dataset in detail. So here we retrieve the first and the only graph in our dataset, and now the data object contains the graph's node features, edge features, and initial labels. So let us convert that into pandas data frame and analyze each of that in detail. So let us print the node features here. So here we can see that these are the nodes features. So it is from this we can see there are total 34 features here, but you can see here that this is basically an identity matrix. So this means that in this dataset, actually there are no features. But for training our graph neural network, we need some features. So we are creating these features. They have these features created as one-hot encoded features. So like we can tell, this is a dummy feature. So in order to train our graph neural network, we are using these one-hot encoded features here. And let us see the number of nodes and edges in this dataset. So let us print the number of nodes. So we have in total 34 nodes here, and we have 156 edges here. So here let us see how these features are getting printed. So as I already mentioned, these are one-hot encoded features, and these are the edge indices in our data frame. So this basically means we have a source node and a destination node, and the edges are formed between the source node and destination node. So in total, we have 156 edges, which are formed between these pair of nodes. So here, let us try to understand this. So there is a node between there is an edge between the nodes 0 and 1. There is an edge between node 0 and 2, 0 and 3. So these edges are formed between this source node and the target node. So in total, we have this 156 edges. And let us print the labels of this data frame. So these are the labels of our data frame. So each of these 34 nodes are having one label. So these labels are the 4 countries to which these students belong to. So each student is labeled with a country, and this is basically a node classification task. Now let us change this. So let us define this number of countries as 4. So we are classifying these students into 4 different countries, and we are randomly assigning these students into one of these 4 countries. So we are using this random.seed for reproducibility. So every time I run this part of code, I will get the same output, or if you run this code and I run this code, we get the same output, which means that the students are each student is randomly assigned to one of the 4 countries. And we update the labels in the data object by using this command. So data.y equal to countries. So this means that originally in our Karate Club dataset, the students are classified into different clubs of that Karate Club. So here we are changing that to different countries. So we change this data dot y into countries. We change these labels into different countries. And now let us verify our data. So this we already explained, but let us see whether the data is as expected or not. So let us print the data shape. So here we can see x equal to 34 by 34, which means that there are 34 nodes in our graph and there are 34 features. So this means that there are 34 students in our dataset and each of these students is having 34 features. So in reality, this is a classification problem. The students are getting classified into different countries. So they are in a university. So these features can be the GPA or the departments to which these students belong to, or the language they speak, or their hair color, or these features can be anything. So in total, we have these 34 features. And here we have edge index as 2 by 156. We have a tensor here. So this means that we have a pair of nodes, which is the source node and a destination node. And there is 156 edges in total between these pair of nodes. And we have this y equal to 34, which means that each of these 34 students is having a biolabel. So each of these students are assigned to one of these 4 countries. So let us see. This is basically a tensor, and you can see each of these 34 students. In total, there will be 34 numbers here, and they are the 34 students in this data set, and all these 34 students will be having one of the bilabels as one of the 4 countries, which is 0, 1, 2, and 3. So this is basically our data. And now let us see if our graph is as expected. So I recommend you to visualize the graph before we start to train our graph neural network. So we can get some insights from that, and we can understand what exactly we are trying to do, and we can get some ideas by looking at our graph. So we will use this network X library for visualizing our graph. So this is an undirected graph, which means that if there is an edge between 2 nodes, it is an undirected edge, which means there is an information flow between the 2 nodes. The information flow is bidirectional. And if you have seen my previous lectures, in that I have explained all these things in detail. What is a directed graph? What is an undirected graph? What are the different types of graphs? So I recommend you to watch my previous lectures so you can get a clear idea about what a graph is, what a graph data structure is, and what happens in a graph neural network, etc. So let us draw our graph. So draw our graph. So our graph is G, and we are using a spring layout for drawing our graph. So this means that we are plotting our graph such that the nodes belonging to the same class are plotted closer, or we are forming a cluster of nodes which belong to the same class. So this will be a forced graph, and we use this command seed.0 because every time we run this piece of code, we will get the same graph again and again. So here I define the node size as 800. You can play with this, and you can see when you change these values, how the graph is getting changed. And we define the node color as data equal to y, which means that there are 4 different countries. So we will get the graph such that the nodes will be plotted in 4 different colors. So each of these nodes belonging to 4 different classes will be plotted in 4 different colors. And we define the C color map here, and we define the width as 0.8 here. This is the width of the edge. So you can try changing that. And I'm using this 0.8 because our graph will be more beautiful. It will not be much crowded. And we define the edge color here. You can try changing this. And finally, we have the font color. So let us see how our graph is getting plotted. So here we have the beautiful visualization of our graph. So initially, when we tried to print our dataset, it was seen that this node 0 was having so much connections, or this node 0 was forming so many edges with other nodes. So maybe this is because this 0 this 0 is a highly social person with so many friends. So this belongs to this violet country. And here we have the 34 different students belonging to 4 different countries. All these 4 different countries are plotted in different colors, which is red, green, purple, and blue. And by using this string layout, we clustered the nodes such that the nodes belonging to same class are plotted more closer. So in the bottom side of this plot, you can see the blue nodes are clustered together here, whereas in the center we have the purple ones. And most of these red nodes are plotted at the bottom side, whereas some of them are scattered here and there. So from this, we can get an overall idea about the students of our dataset. So we can draw some insightful meanings from here, which are the nodes who are more social and which are the nodes who are less social, etc. So you can also observe one thing here. The nodes of the same color have formed edges with the same color nodes, which means that this is a very good pattern, which means that the students tend to interact with other students of the same country. And this is the pattern which we are using to train our graph neural network to classify the students based on the different countries from which they come. So now let us define our GNN model. So here we are using a graph convolution network. So we create a class GCN that inherits from the torch.nn module. So this is a common practice in PyTorch for defining the neural network models. So inside the GCN class, we initialize the model's layers. So in this init method, we define a graph's convolutional layer and the linear output layer. So this super.init class, this is the initializer of our parent class, which is the torch.nn module. So this self.gcn initializes a GCN layer that reduces the feature dimensions from the input features to 3. So in our case, the input features were 34. So it is getting reduced to 3. And here we have our self.out, which defines a linear layer that outputs the number of classes, which is 4 in our case, which represents the 4 different countries. And next, we define the forward pass of our model, which specifies how data is flowing through our network. And this self.gcn, h equal to self.gcn, this passes the input features through the GCN layer, and we apply a ReLU activation function here. And finally, this set equal to self.out, this transforms the GCN's layers outputs through the linear layer to produce the final logits, which we will compare with the label class, and we calculate the accuracy. So let us see how we can do that. Now let us print our GCN model, and let us see the layers of our GCN model. Let us verify that. So here we have our model. So we have all these input features, output features, and everything. So here we have this input features as 3 and our output features as 4. So basically here we are using a graph convolution layer with a single GCN layer. So also we have this ReLU activation function and the linear output layer. So we have a 3-dimensional hidden layer here. So it is interesting to note here that you will have a curiosity why we are using a single layer here. So what if we add a second layer? So if we added a second GCN layer, then our model would not only aggregate the feature from its neighbor of that each node, but also from the neighbor's neighbor. So if you have watched my previous lecture, in that we have discussed about the message passing and message aggregation mechanisms of a graph. So in that we said all the nodes of our graph will gather information from their neighbors in order to update its features. So it is by updating these features, by using the connections between the nodes, our graph is learning, and we are calculating the updated features. So if we add a second GCN layer, then sometimes what will happen is we can try stacking different graph layers to aggregate more and more distant nodes. So like we gather information from the neighbors, from neighbors, and from neighbors. So we can gather information from the distant nodes by stacking different graph layers here. But if we add too many layers, the aggregation becomes so intense that all our embeddings will look ending up the same. So we call that problem as over smoothing. So in order to avoid that, we have to optimize our model, and we have to find the optimum number of graph layers which we can use. So this is a basic project. So we are using just a single graph layer here. But I recommend you to play with this, try adding different graph layers, and try modifying this network, and try to analyze what is happening there. So we can gather a lot of insights from that. And next, let us train our model. So in order to train our model, we need to define a loss function and an optimizer. So here we are using cross entropy as our loss function. So this is because this is basically a multi-class classification problem. We are trying to classify the students based on the different countries. So this is into 4 countries. So basically this is a multi-class classification problem. So we are using this cross entropy loss function here. And in order to have an efficient training, we are using Adam optimizer for having a good training. So here you can see this torch.nn cross entropy computes the cross entropy loss function between the predicted and the true labels, and torch.optim this Adam. This initializes the Adam optimizer, and here we have a learning rate of 0.02. So you can try changing this learning rate, and you can see what is happening here. And how we are calculating accuracy is this pred y command. This converts the logics into the predicted class labels, and then we calculate the accuracy, calculate the ratio of correct predictions to the total number of samples in order to calculate the accuracy of our training. Now let us set up the training loop. We are training our model here for 200 epochs, updating the model parameters in each iteration and training loss and accuracy. So first we will store our embeddings, losses, accuracies and outputs for our later visualization. So here this optimizer.0.grad, this clears the gradients from our previous step, and we perform a forward pass through our model to get the hidden output states. Then this loss dot criterion, loss equal to criterion command computes the loss between the predicted and the true labels, and we perform a backpropagation to compute the gradients here, and this optimizer dot step, this updates the model parameters based on the gradients. So during training, we store the accuracies and accuracy loss and the embeddings, which we can use for the later visualization process. And also during each epoch, we print the accuracy and loss over each 10 epochs here. So here we can see our accuracies and loss during each 10 epochs. So we are getting an accuracy of 97% here, and now we have set up our GCN and we set up our training here. So now let us visualize how we can visualize our training process. So we create an animation here to visualize how the node classification evolved over our training epochs. So let us import the libraries which are required for this visualization and for creating this animation. So we use this IPython display for displaying these animations within our notebook, and this is very interesting, and we use matplotlib library or matplotlib animation to create our animation, and we also ensure we are getting high quality like this will be like an animation, so we are ensuring we get high quality video output by using this command by setting this to 3000 here. Next, we define our animation function. So this function will be called for each frame of the animation by updating the graphs visualization with the current node classification and the training metrics. So here we use network X library for drawing our graph. So G is our graph, and we are using this command to convert our graph into this network X data object. So this is our graph, and this is an undirected graph. So if you have watched my previous lecture, in that I have explained what is directed and undirected graph. And now let us draw our graph by using this nx.draw, and we are positioning our nodes by using this spring layout. So this ensures that the nodes belonging to same class are clustered together, and we use this seed equal to 0 in order to ensure the reproducibility of this graph. So if we use this command, then we will get the same graph every time we try to run this code and every time we plot our graph. And here we set our node size. So you can try changing these node size, edge color, edge width, etc. So here we are setting our node size to 800, and the node colors will be the outputs. So we have four classes here. So we will be having four colors of nodes here. And we give our color map as this, and our edge width is 0.8. So this will ensure that our graph is not too crowded, and our edge color is gray, and the font size is 14. So you can try changing these, and you can make this graph more visually beautiful. And since this is an animation for each epoch, we will print our accuracies and number of epochs and the losses here, and we will plot our animation here. So finally, we will use this HTML equal to HTML anim to HTML5 video. So this command is used for, we are trying to plot our graph within this notebook. So since this is an animation, in order to plot our graph within this notebook, we have to convert it into this HTML video format. So now let us run this code and let us display our graph. So this is our video. So here you can see this is very interesting. Starting from one color, all nodes having one color, our graph is learning, and now each of these nodes are changing its colors and it is getting classified into one of these 4 classes. So finally we have these nodes which are classified into 4 different classes. So here the nodes are the students and the classes are 4 different countries. So these students are getting classified into these 4 different countries based on their social interaction network. So how our graph does this is, first it randomly assumes all nodes belong to same class, and then by using our graph convolution network, it tries to gather information from the neighboring nodes, and it updates its features based on the neighboring nodes features, and this learns the patterns in our graph, and based on this it is calculating the accuracies and losses and embeddings, and our graph neural network is classifying the students into 4 different countries, and we get the final output like this. So we are getting 97% accuracy here, and we have a very beautiful visualization of our graph in the form of this animation. And next, let us try to visualize our embeddings. So here we are trying to visualize our final embeddings of our nodes after training. So these embeddings are learned representation of our nodes in 3D space. So here we see our final embeddings for each node, each represented by a 3-dimensional vector. So these vectors capture the position of each node in the learned embedding space. Now here we will run this, and here we get the final embeddings of our nodes. So we can see that these are 3-dimensional vectors of our nodes. Now let us see how we can plot our embeddings. So how we are plotting these embeddings is, first we will convert this final embeddings into a NumPy array for plotting. So here you can see that we are converting our embedding into a NumPy array, and then we are plotting our final embeddings by using this matplotlib, and also we are trying to animate similarly like we created an animation for our graph. We are using this animate function to create an animation for our embeddings, like when our graph neural network is learning, we are trying to plot this final embeddings as an animation here. So by running this code, we get our final embeddings as this. So here we can see the same color nodes are clustered together in this 3-dimensional space. And in this 3D plot, each node each node represents the final embedding of that corresponding node. And each color represents the different labels. Here the different labels are for different countries. And we can also see here how the nodes are clustered together based on their learned embeddings. So the blue ones are clustered together here in this 3D space. Green ones are clustered together. The purple ones are clustered together, and the red ones are here. So it is a better visualization for understanding our node classification task here. And let us try to understand how this is getting how our model is learning this and classifying our nodes. So in order to make this more interesting, we try to understand the training process by animating the evolution of these embeddings over epochs. So here we can see over in the first epoch, it is randomly assigned, and as our model learns this, the nodes are getting, same colored nodes are getting closer and closer, and finally after 200 epochs our embeddings looks like this. Let me pause here. So here the same color embeddings are moving closer and closer, and our final embedding is like this. So this is very interesting way to visualize our nodes. This is a very interesting way to visualize our nodes in this format. So overall, in this notebook, we tried to classify the students of a university based on the countries from which they come. So we trained our graph convolutional network, and we used we modified the Karate Club dataset, which we imported from PyTorch Geometric Datasets library, and we modified the Karate Club dataset into the dataset of students coming from different countries in a university. And first, we tried to understand our dataset by converting it into Pandas data frame, and we printed the number of nodes, number of edges, node features, and edge features, and we got a clear idea of why and how we are using this dataset for analyzing our social interaction network. And finally, we calculated the final embeddings of our graph convolution. And finally, we calculated the final embeddings of our nodes by training this graph convolutional network. And we tried to create beautiful animations of this graph and how the graph is getting trained and how the students are getting classified. And we also try to create a beautiful animation of the evolution of node embeddings over the epochs. So I hope all of you enjoyed this lecture, and in the coming lectures, we will try to learn what are the different types of graph neural networks like graph convolution network, recurrent graph neural network, graph autoencoders, etc. So stay tuned for the next video. I hope all of you enjoyed this video. Thank you.